Good day everyone. So we are the last reporter for the project management. Our report is all about project resource allocation. So here's my group members. Okay, objectives. So differentiate crashing and fast tracking to expedite a project. Second, define resource loading. Compare and contrast resource loading from resource leveling. Discuss the nature of activity slope and how it is indicated. Identify priority rules and what priority rule is best overall. Name 3 efficiency criteria that might be considered when choosing a multi-project scheduling system. Recognize the average resources load factor and its use to determine project completion times. And lastly, distinguish the differences of late start time, early start time, and early finish time. So, projects involve resource problems. So, these difficulties include trade-offs, the differences between allocation to one project and allocation between multiple projects, the relationship between resource loading and labeling, and some of the approaches employed to solve allocation problems like the critical path method, constrained resource diagramming, and scheduling. So, Goldratt's critical chain is one of the several approaches to the problems of scheduling under condition of resource scarcity. So, it starts with resource conflicts in a single project and extends to the multiple project case. So, although CPM is not actually a resource allocation method, it could be viewed as a time resource and trade-offs between time and other resources in resource management. The project manager's ability and willingness to deal with resource loading and labeling has a major impact on project management. So, critical path method or CPM, expediting a project, is somehow similar to program evaluation and review technique or yung PERT. So, originally, there is one important difference, that is CPM includes a way of relating the project schedule to the level of physical resources allocated to the project. So, it allows the project manager to trade time for cost or vice versa. So, in CPM, there's two conditions. First, normal, in the same sense as the M time estimate of the 3 times used in PERT. So, normal time is the amount of time initially planned to complete the activity. So, second is yung crash, result an attempt to expedite the activity by the application of additional resources like overtime, special equipment, and additional staff or material. So, crash time is the amount of time that activity will take if the additional resources are expended. Crash time is not the time saved, rather it is the reduced time applied. So, it is standard practice with PERT or CPM to estimate activity times under the assumption of resource loadings that are normal. To discuss a time requirements for any task without some assumption about the level of resource devoted to the task makes no real sense. At the same time, it does not make sense to insist on a full list of each and every resource that will be spent on each of the hundreds of activities that may comprise a PERT or CPM network. Clearly, there must have been some prior decision about what resources would be devoted to each task. But much of the decision making is, in practice, relegated to the common methods of standard practice and rules of thumb. Next, the allocation problem requires more careful consideration if it is decided to spend up the accomplishment of task and or the total project. So, it is important to come up with detailed estimates for all the project cost. Once this is compiled, you adapt the cost estimates into a budget plan. It is now possible to track the project according to that budget while the work is ongoing. So, there is a need to know what additional resources it will take to shorten completion times for the various activities making up the project. Projects often get delayed and you have to compress the schedule. Fast tracking and crashing are two ways to do that. So, crashing a project. While standard practice and rules of thumb are sufficient for estimating the resource needs for normal progress, careful planning is critical when attempting to expedite a project. So, crash plans that appear feasible when considered activity by activity may incorporate impossible assumptions about resource availability. So, yeah, take this situation as an example. So, can a crane be hired from Bohol, or will the company bring its own crane in the project site? So it goes, when a project is expedited, there is a tendency to create problems, and the solution to one problem often creates several more problems that require solutions. So, difficulties notwithstanding, the wise PM adopts the scout motto, be prepared. If deterministic time estimates are used and if project deadlines are firm, there is a high likelihood that it must be necessary to crush the last few activities of most projects. So, use of the three probabilistic times estimates of PRT may reduce the chance that crushing will be needed because they include identification and estimation of risk and uncertainties that are sometimes forgotten or ignored when making some projects. Things such as last-minute changes in client specifications and having no permission to extend the project deadline by an appropriate increment are examples of these uncertainties. So, we will be using this formula. Slope is equals to crash cost minus normal cost over crash time minus normal time. So, slope represents the cost per day of crashing a project. So, by the way, crash cost, the cost associated with selecting the faster alternative to complete the effort. Crash time, the amount of time that activity will take if the additional resources are expended. An implication of this calculation is that activities can be crashed in increments of one day. Often, this is not true. A given activity may have only 2 or 3 technically feasible durations. The pesos per day slope of such activities is relevant only if the whole crash increment is useful. For example, if an activity can be carried out in either 8 days or 4 days with no feasible intermediate times, and if uncrashable parallel part goes critical when the first activity can be reduced from 8 down to 6 days, then the last 2 days of time reduction are useless. So, there could be times when the PM may expedite activities that have little or no impact on the network's critical time, such as when the resources used must be made available to another project. So, here's an example of 2 times CPM. So, and this one is the results of crashing a project. So, crashing a project results in a change of that technology with which something is done. In the language of economics, it is a change in the production function. So, project crashing is when you shorten the duration of a project by reducing the time of one or more tasks. Crashing is done by increasing the resources to the project, which help make tasks take less time than what they were planned for. Of course, this also adds to the cost of the overall project. Therefore, the primary objective of project crashing is to shorten the project while also keeping costs at a minimum. So, not only do changes in technology tend to produce discontinuities in outcomes, they also tend to produce discontinuities in cost. As the technology is changed to speed a project, the relationship of input cost to activity duration is apt to jump as it requires moving from less to more sophisticated production systems. So with CPM, the first thing to do is develop a table or graph. Second, starting with the normal schedule. Then third is crush selected activities. So in crushing a project, there is two principles. So the first one is focus on the critical paths when trying to shorten the duration of a project. With the exception noted above, when a resource used by an activity not on the critical path is needed for another project. So, crushing a non-critical activity will not influence project duration. Two principle, when shortening a project's duration, select the least expensive way to do it. So, next, fast tracking a project. So, another way to expedite a project is known as fast tracking. So, this term has been applied mostly to construction projects, but the technique can be used in many other types of projects. So it refers to overlapping the design and build phases of a project. Because design is usually completed before construction starts, overlapping the two activities will result in shortening the project duration. So beginning to build before design is completed might also, however, result in an increased number of change orders, subsequent loss of productivity, increased cost, and loss of time. So, studies of construction projects revealed, however, that while there were more design changes in fast-track projects, the total number of project change orders was not significantly different than in similar projects that were not fast-tracked. So, fast tracking seems to be a reasonable way to expedite construction projects as well as other types of projects when the early build or carry out steps are purely routine and well understood. So it is partial use of the basic concept in phase gate project management and is dependent on effective feedback and feed-forward communication. So I'm gonna show you some differences between fast tracking a project, or rather fast tracking and crushing. So here's. So thank you for listening.